Alright guys, let's see how we can solve question 6 from the chapter 7 of the Hibbeler textbook Engineering Mechanics. And in this one, we need to determine the distance A as a fraction of the beam's length for locating the roller support so that the moment in the beam at point B is 0. So what we want at the end of this is the moment that we have at point B, we can call it MB has to be 0. It's the bending moment at point B. So first of all, we can start with finding the reaction at point C, and if we find that, we can just go for the free body diagram of this part, and since we know MB is 0, we should be able to find the distance A for his question. So before that, let's start with the free body diagram of the whole beam. So we're gonna have the length of the beam, we have a pin at point C, which means we have CX and CY. This force is missing in the figure, so this one is also P. So we're gonna have the force P in here, another force P in this part, and at A we have a roller, which means we have a normal reaction at that support. And what we are interested is all the reactions at point C. If we do sum of all forces in x directions, call our xy in here, we can see the only x component in here is cx, which means our cx is 0. And if we want to find cy, we just have to do the moment about point A. That way we can get rid of all the unknowns at A. And we're going to have the moment of cy about A, which is counterclockwise, so positive. And we need the distance from C to A, which is basically L minus A. So we're going to have the moment of this P force. This one's clockwise, so we have a negative moment minus P times the distance for here. We know this distance would be L minus 1/3 of L, which will be 2/3 of L. And if we want to find this part, we basically have 2/3 of L minus A. And the last force is the other P in here. This P is also making counterclockwise moment about A. So also positive P times the distance from A to here. We know it's A. And this will be equal to 0. And now we can find our cy in here, which would be P 2/3 of L minus A minus P times A over L minus A. So on top of this ratio, we have PL, or 2/3 of PL minus PA minus PA divided by L minus A. So this will be minus 2PA. We can factor P in here. Actually, we can factor 2P in here. P from the first one we get 1/3 of L, and from the second one we get minus 1 divided by L minus A. So that's going to be our CY. Sorry, the minus A. So we have 1/3 of L minus A. From this one we get A. So now we can move on to the free body diagram of this part. So basically we have this part of this beam, which we have our CY, what we found in the previous step. And also we know we have the bending moment of 0, and this distance in here would be 1/3 of L from the previous part. So now that we have this, if we want to find the moment about B, or the sum of all moments about B, we basically have the moment of CY, which is the force times the distance. The force is in this direction, so the moment will be counterclockwise, but the direction here doesn't matter because it will be equal to 0 anyways. So our CY times the distance, which is going to give us the moment, CY times 1/3 of L will be 0. So what we found for Cy was 2p times 1/3 of L minus A times over L minus A times 1/3 of L will be equal to 0. And we have A times B equals 0, which means A can be 0 or B can be 0. We know this part, which is our B, cannot be 0 because the length of the beam cannot be 0. So that does not work, which means this part has to be equal to 0, or 2p times 1/3 of L minus A has to be 0. Again, the force is not 0. This part has to be 0. So our A is equal to 1/3 of L. And that's going to be the final answer for this question. Hope everything was clear. Let me know if you guys have any questions, and you guys take care. I'll see you in the next video.